we shall move to the next exercise. So this exercise depends on only one formula, which is nothing but integral e power x into f of x plus f dash of x is equal to e power x into f of x plus a constant c. So this we derive with the help of integration by parts. Okay. So how I can derive this one? If I want to find out the integration of LHS, consider integral of e power x into f of x plus f dash of x dx is equal to integral e power x into f of x dx plus integral e power x into f dash of x dx with the help of properties of integration. Okay. Now, so I want to evaluate this one with the help of integration by parts. So in that I take e power x as v, f of x as u. So as per the formula, what we get? U integral v. U is f of x. Integral v. Integral e power x is e power x. Okay. Minus integral du by dx. Derivative of f of x is f dash of x. Integral v. Integral e power x. E power x. Plus integral e power x into f dash of x dx. Now these two gets cancelled. We get the answer as f of x into e power x plus a constant c. Okay. So this is the derivation of the given formula. So if I have a function, derivative of a function like f of x plus f dash of x into e power x, then its integral is nothing but equal to f of x into e power x. So we do few problems based on this formula. So I have a question. Integral e power x into sin x plus cos x dx. So in this particular problem, deciding f of x is the main important criteria. So if you are able to identify f of x and we can able to find f dash of x, just you compare with that formula. So if that particular thing satisfies the formula, you can go with the answer as e power x into f of x. So I have here e power x, so I should go with the formula. And which one I can substitute as f of x? If I take sin x as f of x, its derivative is cos x, which is nothing but f dash of x. So I have like f of x plus f dash of x e power x dx. So my answer is e power x into f of x is nothing but sin x plus a constant c. Next, e power x into log x plus 1 by x. E power x into log x plus 1 by x dx. Here what will be my f of x? So can I able to take 1 by x as f of x? If I take 1 by x as f of x, its derivative is minus 1 by x square. So I cannot take f of x as 1 by x, but I can take log x as f of x. Its derivative is 1 by x. So f of x is log x. F dash of x will be equal to 1 by x. My answer, e power x into log x plus a constant c. So later e power x into tan x plus 1 into secant x. E power x into second one, e power x into tan x plus 1 into secant x dx is equal to e power x into f of x plus c. E power x into f of x plus c. Identify the function f of x. So I need like e power x into something, but you see here e power x into 1 plus tan x into secant x I have. So I can multiply secant x by tan x plus 1. Then it can be rewritten as e power x into tan x into secant x plus secant x dx. So which is equal to, see here, if I consider secant x as f of x, derivative of secant x is secant x into tan x. So the function f of x is nothing but equal to secant x. So this answer is e power x into secant x plus c. So f of x will be equal to secant x. Next, integral x cos x plus sin x. So what they asked us, integral x cos x plus sin x dx. This is what the question they asked us. So here I don't have any. So if I don't have any, I cannot apply this formula. So I have to go for integration by parts. So this can be rewritten as integral x into cos x plus dx plus integral sin x dx. So here algebraic function, next one is trigonometric function. So this algebraic function I can consider as u, trigonometric function I can consider as v. So if I find the solution for this one, I get u into integral v. So x into cos x minus integral of du by dx. So derivative of x with respect to x is 1 and integral of cos x. Integral of cos x is sin x. Once again go back. U into integral v, integral of cos x is sin x. You identify sin x. Okay. So x into sin x minus integral sin x dx plus integral sin x dx. Shall I explain once again? So I consider x as u, cos x as v. So according to integral uv formula, so integral uv is equal to u into integral v. So integral cos x is sin x minus integral of du by dx. So the derivative of x with respect to x is 1 into integral v. Integral cos x is sin x. Now these two gets cancelled. My answer is x into sin x. Okay. Next problem. Integral of 2x minus 1 by 4x square, integral 2x minus 1 by 4x square into e power x. It's not only x, e power 2x. E power 2x dx. So I have e power x. It's not e power x, it is e power 2x. So I have to convert this in the form of e power x. So how can I convert? By substituting 2x as t. So if I put 2x as t. Next question. Integral x minus 1 by 4x square dx. Similar, e power 2x dx, right? So this is what the question they given, and we need e power x, but we have a e power 2x form. So 2x can be converted into another variable by substitution. So if I substitute 2x as t, so I get 2 into dx as dt. Okay, now replace. So I get integral t minus 1 by t square. So how I get t square? So 4x square can be written as 2x the whole square. Okay, t square into e power 2x can be written as e power t. Dx can be written as t dt by 2. This is what we got. Now we get 1 by 2 because it's a constant. We can take it out. 1 by 2 into, split this one, 1 by t minus 1 by t square into e power t dt. So if I take f of x as 1 by t, so if it is t, then we have to go with f of t. So f of t is 1 by t, then f dash of t will be equal to minus of 1 by t square. So how we get minus 1 by t square? So f of t equal to t power minus 1 by t. So it is exponent form, n into x power n minus 1, minus 1 minus 1, right? So we get it as minus 1 into t power minus 2, nothing but minus 1 by t square. That's what we got. So this is f dash of t and this is f of t plus. We don't consider this as minus because minus also included in f dash of t, right? So I have f of t plus f dash of t into e power t. So our answer is e power t into f of t dt. So now what is t? Replace t. So 1 by 2 into e power, I consider 2x as t, so 2x into f of t, I consider f of t as 1 by t. So plus a constant c. So I can replace this t as 2x now. 1 by t, f of t is 1 by t, 1 by 2x. So I get 1 by 4x into e power x. So 1 by 2, 1 by t can be written as 1 by 2x. In place of t, I substituted 2x. So can be rewritten as 1 by 4x into e power 2x plus a constant c. So later x into e power x by x plus 1 the whole square. Main first integral x into e power x by x plus 1 the whole square dx. So this is the question given. So I have to split this one because I have e power x now. So I have to split the quotient as f of x plus f of x dash. Sorry, f of x plus f dash of x. So for the purpose, what I am doing, so I can split this with the help of partial fractions. So but it's easy, without going to partial fractions also I can solve. I have in denominator x plus 1 the whole square. So numerator can be written as x plus 1 minus 1 by x plus 1 the whole square into e power x dx. Just added 1 and subtracted 1. So now if I split x plus 1 by x plus 1 whole square, which is nothing but 1 by x plus 1 minus 1 by x plus 1 the whole square into e power x dx. Now if I consider this one as f of x, what about this? F dash of x. So f of x is 1 by x plus 1, f dash of x is minus 1 by x plus 1 the whole square. Just now be solved. If I have f of x as 1 by t, f dash of x is 1 by t is minus 1 by t square. So in place of t I have x plus 1. That's what. So what is our answer? Our answer e power x into f of x, which is nothing but 1 by x plus 1 plus a constant c. So answer is e power x by x plus 1 plus a constant c. Okay. So later one more problem. So the same way they have given x minus 3 by x minus 1 the whole cube. X minus 3 by integral of x minus 3 by x minus 1 the whole cube into e power x dx, right? So in this case what I can do, I can split this minus 3 as minus 1 minus 2. So if I write this one, I get integral x minus 1 minus 2 by x minus 1 the whole cube dx. So if I consider this one as one part, one group, next one group, I can split it. So how can I write integral x minus 1 by x minus 1 the whole cube, which is nothing but 1 by x minus 1 whole square minus 2 by x minus 1 whole cube dx. Okay, so now consider f of x as 1 by x minus 1 whole square, which is nothing but x minus 1 to the power minus 2. So what about f dash of x? F dash of x is equal to n into, so minus 2 into x power x minus 1 power n minus 1 minus 2 minus 1, which is nothing but minus 3. So I get f dash of x as minus 2 by x minus 1 power 3. So which is nothing but this. So this is f dash of x and it is f of x. So our answer is e power x into 1 by x minus 1 the whole square plus a constant c. So later 2 plus sin 2x by 1 plus cos 2x into e power x dx. Second, integral 2 plus sin 2x by 1 plus cos 2x dx. So this can be split as integral 2 by 1 plus cos 2x plus sin 2x by 1 plus cos 2x dx. So I can check which one is f of x and which one is f dash of x. So 2 by 1 plus cos x. So I can write 1 plus cos x as 2 cos square x, right? So 1 plus cos 2x, 1 plus cos 2x as 2 cos square x plus sin 2x can be written as 2 sin x into cos x by 2 cos square x dx. 2 and 2 gets cancelled, 2 and 2 gets cancelled. I get the answer as secant square x plus cos, and here it gets cancelled. So I get sin x by cos x. This is nothing but tan x into e power x. I forgot, otherwise it's not given. Yes, it is given, I forgot. E power x dx. E power x dx. E power x dx. E power x dx, right? So if I consider this one as f of x, f dash of x is nothing but equal to 2e into secant x tan x. I don't have that much of term here, so I cannot take this one as f of x. I can consider tan x as f of x. So secant square x acts as f dash of x. So f of x is tan x, f dash of x is secant square x, e power x dx. So my answer e power x into f of x, which is nothing but tan x plus a constant c. So e power x into tan x plus a constant c is our answer. Next question. Integral sin x into log x plus sin log x plus cos log x dx. Integral sin log x plus cos log x dx. Integral sin log x plus cos log x dx. They didn't give any e power x in this particular thing. So if they didn't give any e power x, so we no need to apply this particular form. We have to go for regular simplifications. So if I consider this one as I, so I is equal to integral sin log x dx plus integral cos log x dx. sine of log x dx into some one I can consider, right? So if I consider this one as u and this one as v, so instead of going for that, I can go with log x as t. If I go with log x as t, so what I get? Let log x equal to t. So 1 by x dx will be equal to dt. 1 by x dx will be equal to dt. Now, if I have log x as t, so what about the x? X will be equal to e power t, exponential form. So I am not going for this into 1 and simplification. So if I want to go for into 1 and simplification, I have sine of log x, function in terms of log x, trigonometric function in terms of log x. So which leads to complexity, more complex. That's why I used substitution. Okay. Now dx can be replaced as e power t into dt. So dx we can replace as e power t into dt. Now I changes as integral sine t into e power t dt plus integral cos t into e power t dt. So now exponential form, trigonometric. So trigonometric term we consider as u, exponential one we consider as v, and we apply integral uv form. So what is integral uv? U integral v minus integral du by here t, no? So I have to use t into integral v dt because the functions are defined in terms of t. So u I consider as sine t into integral e power t is nothing but e power t minus integral du by dt. Sin t derivative is cos t. Integral e power t is e power t dt plus. So no need to apply because these two are plus and minus, we can get cancelled. So cos t into e power t dt. So both are gets cancelled. So my answer sin t into e power t. So I have to express in terms of x. So I get I is equal to sin t is log x. So sin log x plus, it's not plus, it's into e power t. E power t is x. So I get x into sin log x plus a constant, simplest response.